So this particular problem that Nathaniel sent me was from a previous quiz, I believe. But I never, on this one, if I were giving you this one today, I would give you the derivative. So we want a tangent line at x equals 2 pi over 3 when f of x equals x minus sine x. Pretty cool looking graph. Anybody know the derivative for me? Because today I'm going to give you the function, I'm going to give you the derivative. What? Derivative of x is what? Yeah, 1, right? And then derivative of sine is cosine. So we would need to find the y value. So today on the quiz, this is for the fourth quiz for today. There's 4 of them. I'm giving you the function, I'm giving you the derivative, I'm giving you the point. So all you have to do, so that's where we are right now. I have to find the y, I have to find the slope, I have to find the tangent line. So the y is going to come from the f of 2 pi over 3. And of course, 2 pi over 3 is here. So I know sine is positive, and I know sine of pi over 3 is rad 3 over 2. Everybody okay there? So for my slope, I need my f prime of 2 pi over 3. So that is 1 minus cos of 2 pi over 3. Cos in that quadrant is negative, right? Only sine is positive in that quadrant. So cos is going to be negative. So I'm going to have 1 plus the cos of pi over 3. And of course, pi over 3, that's the reference angle, right, is 1/2. How are we doing there? We're okay? So we're ready for our tangent line. Y minus 2 pi over 3 minus rad 3 over 2. I probably will get a common denominator there eventually, but I'm going to wait for now. So that equals 3/2 all times x minus 2 pi over 3. Everyone okay there? Right, we got that equation, our formula y minus y1 equals m times x minus x1 on our formula sheet for today, yes? So y equals 3/2 times x minus 2 pi over 3 plus this other junk, 2 pi over 3 minus rad 3 over 2. And then I'm just going to try and clean that up as much as I can. In this case, it's pretty ugly. Nothing I can do about it. So I get 3/2 x minus pi plus 2 pi over 3 minus rad 3 over 2. We agree with that when I distribute that 3/2, the 3 and the 2 cancel. And then it looks like I'm just going to get a 6 on my denominator here. So plus over 6. I'll take the positive one first, 4 pi minus 6 pi. Oh, I could have done that before. Minus 3 rad 3. So I get minus 2 pi minus 3 rad 3 all over 6. And of course I could take that negative out. I mean, if you gave me that answer, I'd be fine with it. But I like this one better. Yeah, question? Anissa? Yeah, so derivative of sine is cosine. And then negative or coefficients go for the ride, I like to say. So that negative's going to stay out front. So, right? 1 minus? Right? Yep. Oh, I see what you're saying. I did it here. Damn it. Oh, no. So cos of 2 pi over 3 is, right, 2 pi over 3 is in that direction, so cosine's negative there. So it becomes a pos, so that negative I take care of, and then I just change my angle to the reference angle. So I do my trig differently than unit circle things. Yes, question? You're going to have to yell for me. Yell it for me. What do you mean? What? We've done a bunch. We've done a bunch. Yes, if I have time right before the quiz, I'll do another one. I want you getting in the habit of asking for help on problems that you're having trouble with. That means you're sending them to me the night before class. Or if you're working on them in the morning, it's fine. Work on them in the morning and send them to me, right? But I don't like the hypothetical game, right? Like if you say to me, well, what if x was pi over 4? Well, if we're going to play the hypothetical game, what if I was a billionaire? Class is canceled and you all got an A. So we don't have to do the, right? So I'd rather work on problems that you specifically are having trouble with. That's what I want you to do. Now, I do review the whole class before the exam. Okay, so that Wednesday, September 28th, we're just going to practice. All right, but otherwise it's up to you to come to office hours, ask for help, send me questions, right? I'm pretty stubborn. You can ask my ex-wife. I want what I want, and that's it. That's it. Elizabeth? Yes. Is that okay, or is that too zoomed? Fine. Oh, you want pictures? Let's do for one picture there. Go ahead, get that. Yep, and then the rest of it in one picture right there. Yep. Abigail, if there's time, I'll do another one. Okay? Good. I want to look at the one homework problem you have to turn in on continuity. It's a little tricky, I think. Number 47. So this is 2.4, number 47. This is the one you're going to turn in. I'm almost going to do the whole thing for you, but just don't want you to get stuck. So I've got an x cubed minus a cubed over x minus a. That's when x does not equal a. And I want the height c when x equals a. So clearly the first function, right, I've got a piecewise function here, is 0 when x is a. And remember, what's our limit here? Is x moving toward what number? A. So this machine is like a quadratic with a hole at A, right? Is that making sense? I've got some kind of quadratic, and then at A, there's a hole in the graph, right? We're trying to patch that hole with what height? C, exactly. And we want to make sure C is the same height as that polynomial there, right? So this is a pretty cool one to look at on Desmos. Again, when you're taking your quiz today, you must use the school computer on your desktop for Desmos, okay? So let's make sure everything's working where we're sitting, right? So I'll go to Desmos here. and I'm going to put in these two functions. This is a little bit strange. So I'm going to say f of x is x cubed minus a cubed. Of course, that's going to be a slider for us. All divided by x minus a. So you see it's just a yeah, I can't really see where the point missing is. But I can plot the other point. The other point I want is what? X comma, sorry, x is going to a, right? A comma c. And there's another slider. So you can see that point can be anywhere, but depending on where a is, right, I want them to match up. I kind of see where my hole would be. It'd be right about there. Is that making sense at all? So I got to figure out what height that is based on the value of a. So that's the problem. Everyone okay? Desmos working for everybody? Fine. I don't want to talk to you either. Desmos working for it? Yeah? It's okay? So what do I need to happen? I need to have the limit at a of one piece of my function equal to the other piece of the function, right? Is that making sense? Continuity. I need things to match up. This one's kind of weird because it's a single point, right? So I need the limit as x goes to a of x cubed minus a cubed over x minus a to be equal to c. That's what I need, right? That making sense? Question, Jack? Okay, thumbs up. Nice. I don't know. You're probably all too young to know who Fonzie is. Anybody know who Fonzie is? He was in the Happy Days sitcom in the 70s and 80s, and he always just say, "Hey." But I taught I used to teach in Hollywood, California, so I taught a lot of movie star kids, and I had his son. I said, "I'm going to give you an A." He didn't laugh either. Don't worry. Okay. So the limit for that particular function is going to take some work, and of course you already know I'm going to get like a x minus a times an x squared plus ax plus a squared over that x minus a. This is kind of my star function, right? Yeah? So I have to get, I get this guy, I have to get the limit, this x goes to a of x squared plus ax plus a squared equal to c. And so the question is, what's the value of c in terms of a? But it's pretty obvious, right? X is going to a, yeah? So what do I get here? A squared. What do I get here? A squared. What do I get here? A squared. So that's 3a squared. So I'm sorry to do that homework problem for you, but hopefully you can think a little bit and get that understanding. But if I take out c here and just make this thing 3a squared, what are you going to see when I move a? What are you going to see? Huh? It's going to always stay on the curve. No matter where I move a now, right? The point is always staying on the curve. It's always filling that hole. Okay? Nice, let's talk about our new section. We're doing section 4.5 today. So chapter 3 is all about derivatives, right? We're just learning how to take derivatives, but we're going to learn a heck of a lot more. And then chapter 4 is applications of the derivatives. So this is one particular application of derivatives, and that is finding limits. So this is called L'Hopital's rule. It looks like a hospital. L'Hopital's rule. This is a French mathematician that wasn't very good, so he hired other mathematicians to prove things, and he bought them from them. Supposedly, he bought this one from Leonhard Euler, and so put it under his own name. But it's really a beautiful, beautiful function, a beautiful proof. And that is, if f of c equals g of c equals 0, then the limit as x goes to c of f of x over g of x equals the limit as x goes to c of f prime of x over g prime of x. Now, when we do these problems, we're not doing any limits with any derivatives with limits. We're just going to use shortcuts, okay? And we know a bunch of shortcuts, right? We've got a whole long list of shortcuts. And around chapter 3 somewhere, we'll list every one we have, okay? Because we're going to learn more in 3.1, 3.2, 3.3, 3.4. 3.4 is the chain rule. That's the one I'm worried about. I usually will lose a couple students with the chain rule. So you want to really be caught up with everything we do before we hit that one section, 3.4. So I'll prove this to you today, but let's just do a couple of examples real quick, right? Well, let's just do the one we just had. The limit as x goes to a, what was it, x cubed minus a cubed over x minus a, right? Clearly, if I plug in a here, I get 0 over 0. We agree? If I plug in a, we get 0 over 0. So I know I can apply L'Hopital's rule. There's two ways I would like you to identify that you're using L'Hopital's rule. The easiest one is to say, I want to look at the limit as x goes to a of x cubed minus a cubed all prime. So that means take a derivative over x minus a all prime. So that on the paper, you're communicating to me that you're about to apply L'Hopital's rule. And when can I do it? Anytime I get 0 over 0. Also, I can do it when I get infinity minus infinity. I'm sorry, infinity over infinity, infinity minus infinity, infinity to the 0, and 0 to the infinity. Question? Yeah, like this, and I'll show you. Or sometimes I'll do a little hop. I'll say take a little hop there. Yeah, question. One more time. Of the shortcuts, I think it's around 3.6. It's a nice little gray box in the book on one page. But, you know, we did it a bunch of times. Derivative of ln is 1 over x. Question? Oh, in 4.5. If you read 4.5, it'll show you all the indeterminate forms. We're only going to do 2 this semester. 0 over 0 today. Infinity over infinity on Monday. And Calc 2, you'll do all the other ones. So I think both these derivatives are pretty darn easy. Yeah. Scroll up. So these are pretty darn easy. What do I get for the first derivative? 3x squared minus 0. A cubed is a number. And downstairs? 1. So I'm really just looking at the limit as x goes to a of 3x squared, and of course that's 3a squared. What do you know? Same answer that we got before, right? Yeah, so bring down the power, reduce the power by 1, so 3x squared. A cubed is a number, so derivative is 0. A cubed is a number. So like if y equals 2 cubed, that's 8. That's a horizontal line at 8. What's the slope of that line? 0. Probably not the best one to start with, but we just did that problem, so I thought it would be interesting to look at it. It's confusing with the a in there, but you know, if you're ever confused by a variable, you can just put a number in and think about it that way. Let's do this one. Limit as x goes to 0 of sine of x over x. What do I get there? Sine of 0 over 0, right? What is sine of 0? Sine of 0 is 0, yes? I'm always, whenever I'm doing the problem like that, I'm always drawing my sine curve and I'm saying, where's sine of 0, right? So I need to take a little hop. So I'm going to do the limit of, as x goes to 0, what's the derivative of sine? Good, what's the derivative of x? So now I can just plug in my cos of 0 and I get 1. So the limit of sine of x over x is 1 as x goes to 0. Let's do another one. Let's see, the limit as x goes to 2 of 1 over x minus 1 and 1 over x squared, minus 1/2, and 1 over x squared minus 1/4. Remember what we'd have to do on this one if it was algebraic. What would be our LCD? Not 4x. 4x squared would be the actual LCD. A common denominator would be 8x cubed if I just multiply them all together, right? Both will work. One will make you factor more. But we know we get 0 over 0 here, so let's apply L'Hopital's rule and say 1 over x minus 1 over 2 quantity prime, right? And then 1 over x squared minus 1 over 4 quantity prime. I want the derivative of the numerator only. This is not a quotient rule, for those of you who know the quotient rule. This is derivative of upstairs divided by derivative of the downstairs, reevaluate the limit. Who's got the upstairs for me? Negative 1 over x squared. Is that what you're saying? I can't hear today for some reason. What about the downstairs? So look at y equals 1 over x squared, right? That's x to the minus 2. So y prime power rule, negative 2 times x to the negative 2 minus 1. So negative 2 over x cubed. Yeah. So these are power rules, right? 1 over x squared is the same as x to the minus 2, yes? Power rule. Bring down the power. So the negative 2 goes in front. And then I subtract 1 from the power. Yes, you with me, Abigail? Yes? So same thing happened upstairs, right? Y equals 1 over x is x to what? X to the minus 1. So y prime, bring down the power, subtract 1 from the power. So I get minus 1 over x squared. Double negatives cancel, right? And then I have fraction divided by fraction, yes? Fraction divided by fraction. What do? I keep the first fraction and do the reciprocal of the second fraction. You with me? Abigail, yes? Where are you though? So what do I get? X over 2? So what's the limit? Yep. Question? Right here. This is 2.3, number 30. We ready? Abigail, talk to me. Can't hear you. Yes, we also took the derivative. We took the derivative of the whole numerator, right? The derivative of 1 over x is negative 1 over x squared. The derivative of minus 1/2 is 0. And then we have our new numerator. Same thing. Take the derivative of 1 over x squared minus 1 over 4. I get negative 2 over x cubed minus 0. So I get my new denominator. I simplify. I don't have to. I could go right away to my limit there. And then I plug in and get the limit. It's a lot. Notice, I mean, it's a lot better, easier than factoring, right? Question? You can, but I'm not asking you to do it on this quiz. If I say do it algebraically, yes, it would be wrong to use L'Hopital. Today I want algebraic. Let's do another one. This is 2.3, number 30. Yeah. Yep. What's negative? No, the slopes of y equals 1/2 is 0. The derivative of a constant is 0. It doesn't matter plus or minus a constant, plus a derivative of a constant is 0. Yes. And we talked about y, right? If I look at y equals 7, it's a horizontal line. What's the slope of a horizontal line? 0. So that's why the derivative is 0. Because the derivative is the slope. Right? All right, this is number 30. 2.3, number 30. I'm looking at the limit as x goes to 16. 4 minus the square root of x over 16x minus x squared. If I plug into 16, 4 minus square root of 16 is 4 minus 4, that's 0. And then 16 squared minus 16 squared is 0, right? So I get 0 over 0. So now I know, and even though I didn't prove it yet, I will in a minute, I can use L'Hopital's rule to get this to get this limit. So I'm going to write the limit as x goes to 16 of 4 minus square roots of x quantity prime over 16x minus x squared, that quantity prime. I'm going to take the derivative of the numerator, take the derivative of the denominator, and reevaluate the limit. Downstairs on this one I think is easy. Downstairs on this one is easy, right? What do I get for my derivative downstairs? Nice, 16 minus 2x. Thank you for saying it nice and loud for me. Upstairs is not so easy, but we should have the square root function memorized. I get 0 minus 1 over 2 square roots of x. Everybody with me there? Square root of 4 is 0. Square root of a square root is 1 over 2 square roots, but I'm going to keep the negative, right? Let the negative go for the ride. Let coefficients go for the ride. So I think I can just plug right in here, right? Let's see what happens if I just plug in. Notice my limit notation is gone, right? Once I plug in, I know I already, this is the height. It's not a very pretty height, right? But it's the height, so I don't need the limit anymore. I get minus 1 over 2 times 4 over a negative 16? Yep. So I get a positive 1 over 8 divided by 16, which is 1 over 128. Yeah, question. Did you do so 1 over 8 divided by 16 is 1 over 8 times 1 over 16, which is 1 over 128. So I just did keep, change, flip. Pretty cool, right? That we could do these limits without factoring, without conjugates, right? So why didn't I just teach you this first? Right? Why? What the hell? You should be pissed off at me. Every lecture you should be walking out of here going, "That damn motherfucker." But what did I need to get these derivatives? To be able to get these shortcut derivatives, I needed how to know how to do limits. Like how to start with limits. Right? To be able to get the derivatives, and now I can use the derivatives backwards to go get the height of things. Let me prove this one. You don't have to write it down, but I would like you to agree or disagree with me on every step. So that's either, okay, good, I get it, or wait a minute, what happened? Okay? Yes? So, yes, square derivative of 4 is? So y equal 4 is a horizontal line, right? So what's 0? Yep. All right, here's the proof of L'Hopital's. I don't have any math majors. If I did, I would say you should learn this and know it, but none of you are math majors. Aerospace? Who are my aerospace people? Aerospace, anybody? No? Oh, yeah. So you're going to do as much math as Einstein did. So, dear, Einstein used to say, "You think you got problems." He had lots of problems. So you don't, I would say, math major, you don't really need it. You're going to do a lot of theoretical physics, which is math proofs. So, but you don't have to worry about it now. So I want to show if f of c equals g of c equals 0, then if I'm doing the limit as x goes to c of f of x over g of x, it's the same as the limit as x goes to c of f prime of x over g prime of x. I just restated what I'm trying to prove. And it's kind of interesting thing here. Remember trig identities? You had to prove left side is the same as the right side. And sometimes you would get stuck on the left side, so then you would move to the right side, right? And it's the same thing here. If I started on the left side here, I wouldn't know what to do. But if I start on the right side, it kind of falls apart for me. So I'm going to start on the right side, right? So let f of c equal g of c equal 0, right? And then let's look at the right side. The limit as x goes to c of f prime of x over g prime of x. Well, I know how to get f prime of x, right? Think about it. If this is c and this is x, then I have c f of c, x f of x. And then how would I get my tangent slope out of that? How do I get my slope from there? F of x minus f of c all over x minus c as x goes to c. So it's the limit as x goes to c of f of x minus f of c all over x minus c. That's my derivative. That's f prime, right? You with me there? That whole thing here that I've got in green, oh, that's almost green, is f prime. Right? So I want the same thing downstairs with g. The limit as x goes to c of g of x minus g of c all over x minus c. Well, it's a little, yes, we okay here so far? It's a little redundant. Right? I'm saying, oh, I want x to go to c. And then, oh, I want x to go to c for this. And I want x to go to c, I want x to go to c for this. So I just need x to go to c. So I've got this limit written 3 times, I only need it written once. We agreeing with everything so far? Every time I have this limit as x goes to c, it means x go to c. Why do I have to keep saying it? I don't. So I just need x go to c for f of x minus f of c over x minus c, and g of x minus g of c over x minus c. Says the same thing. I don't need to keep saying, hey, let x go to c. Well, also let x go to c. Also let x go to c. Right? I don't need to keep saying it. Right? Matthew, you got your mask today? I'm sorry, man. It's going to be over soon. It'll be over soon. Even the class will be over soon, thank God. See anything? See anything in my proof that I can do? Cancel what? Cancel the x minus c. Or keep change flip and then cancel them if I have to, right? But I'm going to just cancel my x minus c's. Yeah, you're not writing this. No. No. You don't have to. Okay. So tell me where you're at. So like What I'm trying to get you all to be able to do are problems. I don't care about the theory. If you were math majors, I would care about the theory. But math majors, as a junior, will take Advanced Calc 1 and Advanced Calc 2. So that's when you learn how to prove everything. Okay? So all I want you to be able to do is the problems. So when you get a new limit of 0 over 0, now you know L'Hopital's rule. Take the derivative of the upstairs using shortcuts, take the derivative of the downstairs using shortcuts, and redo your limit. But here, I just want to see if you can follow the proof, because I think it's elegant, I think it's beautiful, right? So, but it's not required of you. You just have to know how to do limits, right? Look at my old chapter 2 test. First problem on every test is find this limit algebraically, then redo it with L'Hopital's. And make sure you get the same. Of course, you're also going to use Desmos and get the numeric answer. And then you'll know which of your limits are right or wrong. If they match and it matches Desmos, you got it. Move on. Don't look at that problem again, right? If one of your answers matches Desmos, that's the one you got right. Do the other one over. New piece of paper, probably. Right? So what do I get now? I get f of x minus f of c all over g of x minus g of c. But we know something about f of c and g of c. There's 0. So I get the limit as x goes to c of f of x over g of x. That's what I wanted. And so usually at the end of a proof, we say something like QED. It's Latin for I told you so. Quaderat demonstratum. So there it is. Kind of got it it backward, but still I see right, the limit is x goes to c of f of x over g of x. Same as the limit is x goes to c f prime of x over g. But I have to have that stipulation that I get a 0 over 0. Thanks. One more? Oh, we have no time. No time.